Right, last question. Woo! Question 9. This is all about series. It's about geometric series. Don't let the fact that it's a big question with logs in and stuff put you off. Just take each bit at a time. It's actually not that bad. First bit is just 2 1-mark questions, so it should be easy. So we've got an adult population of a town, 25,000 at the end of year 1. The model predicts that the adult population of the town will increase by 3% each year, forming a geometric sequence. What you need to know and realise before reading anything, that if it's increasing by 3% each year, then your multiplier, your common ratio, is 1.03. If you're finding 3% of something and adding it on, increase, then you're multiplying by 1.03. If it was a decrease, which it can be sometimes, then you will be taking off 3%, so it'll be 0.97. If any of that confuses you, you need to go and speak to somebody. You must know that. Then knowing that, the rest is pretty straightforward. So it says, show that the predicted adult population at the end of year 2 is 25,750, and then write down the common ratio. We've already got the common ratio. So we'll do it on a different page. Part A, show that the predicted adult population at the end of year 2 is 25,750. Even if you didn't know this meant times by 1.03, you could do it in your own way. All you're doing is getting the year 1 amount, which is 25,000, and you're finding 3% and adding on. But it's much easier if you just times by 1.03. So you're doing 25,000 times by 1.03, and you should get what they want. Let's double check. 25,000 multiplied by 1.03, 25750. 25750. So that's part A. Part B, write down the common ratio of the geometric series sequence. It's the 1.03 because that's what you're multiplying by. Done. So that's 2 marks. The next part, the model predicts that year n, so this is on about a term, we're not talking about any sums, just a term, will be the first year in which the adult population of the town exceeds 40,000. Show that this. Now, like earlier, I've said before, don't let this put you off. Just write down what you know about this, and hopefully, eventually, you'll get here. So don't let that bit put you off. So they're on about a year n, they're not on about a sum, so they're on about the nth term. You can use your formula book to look up the nth term rule, which is this. Get off. AR to the n minus 1. So to find any term, you just do AR to the n minus 1. So it says in year n, it'll be the first year where the adult population of the town exceeds 40,000. So AR to the n minus 1 will exceed 40,000. Now, do we know anything about that? We don't know n because it's saying year n. We know what A is because it was the first term in the, which was 25,000, and we know what R is, it's 1.03. So let's just fill the bits in there. So we've got 25,000 multiplied by 1.03 to the n minus 1 exceeds 40,000. So even without attempting to answer this part here, we've just written down what that says with some maths. And now when you look at that, it doesn't look as bad because there's the inequality sign, there's n minus 1s, and there's logs, but logs are because we're going to bring this power down. If you're going to try and solve this, which we do need to for part D, then you would always want to use logs to get the unknown down on the ground. So before we use log laws, we need to get this bit by itself. We need to get rid of this bit here, so we need to divide by 25,000. So we've got 1.03 to the n minus 1, divide by greater than 40,000 divided by 25,000. So 1.03 to the n minus 1 is greater than whatever that is. 40,000 divided by 25. 25,000, and that is 1.6, which is nice and pleasant. Remember, I'm not trying to solve it just yet. I'm just trying to get to this part. Now we bring in the logs because we've got this bit by itself now. And when we do logs, log both sides, we'll get this. And then bring this power to the front, which is what we want. So n minus 1, because they're using capital N's, it's because they said yeah n. So technically, I suppose we should always have capital N's just for this question here, just in case they're picky. There we go, easily fixed. N minus 1, lots of log 1.03 is greater than log 1.6, and that's exactly what they've got there. So that's 3 marks for getting to that point. Now for part D, we have to find the value of n. So what's nice about this question is if you did struggle to solve this, you can still you can still get your 2 marks for finding the value of n because they've given you the inequality here. So taking this, or this one here, we're going to find the value of n. So what you need to do first, we're getting n by itself, so we want to get rid of this number here. So we've got n minus 1, log 1.03, that's just a number, and log 1.6 is a number. Divide by log 1.03, it's not a negative number, so you don't have to flip the inequality sign. And that will give you n minus 1. Now, because I'm lazy and I don't have time to, or room to write it, I'm going to take the 1 over now and make it plus 1. So n is greater than that plus 1. So n is greater than, I'm going to type this in. So log of 1.6 equals that, divided by log of 1.03 equals that, plus 1, don't forget to add that 1. We get 16.9 something something something. And n can't be a decimal because it's a term, it has to be a whole number. So n is equal to 17. Done for that part. Next bit, E. It says at the end of each year, each member of the adult population of the town will give £1 to a charity fund. Assuming the population model, which we just looked at, find the total amount that will be given to the charity fund for the 10 years from the end of year 1 to the end of year 10. Give your answer to the nearest 1,000. Right, so this is actually just a sneaky way of getting you to sum them up. If every person is given £1 at the end of each year, then in the first year, it's going to be the 25,000 that it started off with. In the second year, it's going to be, can't quite remember what it was, 25,750. In the third year, it's going to be whatever 25,750 times 1.03 is, all the way to the 10 years. So it's that many pounds because it's £1 per person from each person in the population. So it's that many pounds plus that many pounds plus that many pounds, all the way up to that. So it is a summation one. If you use your formula booklet, the sum of the first n terms is a lots of 1 minus r to the n over 1 minus r, or r to the n minus 1 over r minus 1, doesn't matter which one you use. And we're just going to fill in the bits we know, and hopefully we'll get the nice sum. It does say give your answer to 1,000, the nearest 1,000. So the hardest bit about this really is it's not telling you to find the sum. You've got to read it, understand the question, and realise you're just finding the sum of the first 10 terms. But you could guess that anyway because it hasn't asked you to do that yet, and they usually want to assess that you can do that in an exam. So even if you couldn't understand it, you have a good guess and sum it up. So the sum of the first 10 terms is A, which is 25,000, multiplied by 1 minus 1.03 to the n, 0 divided by 1 minus 1.03. If you want to switch those round so it's r minus 1 and r to the n minus 1, you can. It makes no difference whatsoever. Type that all in a calculator. It may take me a while. 25,000 multiplied by 1 subtract 1.03 to the power of 10 is that number, divided by 1 subtract 1.03, and we get 296,596.98, blah blah blah, to the nearest thousand. That's going to be £287,000. Completed.